I'm Professor D.K. Panda from the Ohio State University. Together with my colleague, Professor Hari Subramani and Navaras Al Nasan, we are very excited to bring you the tutorial on principles and practice of scalable and distributed deep neural networks training and inference. This tutorial is targeted to be offered at Supercomputing 2024. If you know, we are in a very exciting world. The field of AI is changing quite a lot of things. And in that context, we are seeing a lot of developments taking place with respect to machine learning and also deep. Now, these concepts in the machine learning, deep learning are nothing new as of now, but they have been there, even as you can see here, almost from the last 100 years. But a lot of changes are happening with respect to networking technologies and especially HPC systems with CPUs, GPUs, and all. And that is actually helping us to really make strong progress in trying to provide newer kinds of solutions in the field of. Now, a lot of common examples you might be encountering in everyday's life, like a credit card fraud detection using on big kind of simulations, AI-driven simulations, generating arts by understanding the behavior of how the painters have been painting over the years, and even very simple examples of like a even the Google. Now, as these applications, the machine learning, deep learning applications are increasing in their size, obviously there is a need of parallel training. As you know, the language models like the ChatGPT and all have been continuously evolving with a very large billions of parameters. Same thing is happening with respect to vision models, and and especially these kind of models require a lot of memory, a lot of computation, and even sometimes they cannot even fit a single GPU memory. So if you're just trying to utilize a single node servers or a CPUs or GPU or even a collection of GPUs within a single node, you may not be able to scale of the training of these applications, the models. So this is where the community has been moving into the multi-GPU training. And this is where there is a big significance these days with respect to multi-node distributed. And so in this context, you might be asking yourself, the questions, many of these questions like, can we understand the DNN training performance in a holistic manner? If I run it on multiple GPUs, how do I know that how much time it will be taking for my training as well as for inference? How I can correlate the low level performance to high level metrics? Can we utilize the existing HPC systems, the MPI runtimes, or if not, what additional changes need to do? And if the data is not fitting into the model and data is not fitting into a single GPU, then how I can handle out of code DNN, and what are the kind of the open issues at the intersection of DL and HPC, and especially the modern GPUs like from NVIDIA, AMD, and Intel, how to exploit these GPUs for machine learning and deep learning, and especially with respect to distributed training and inferencing, how I use that in the context of also the machine. So the broad challenge the community is facing these days is how to efficiently scale out machine learning and deep learning frameworks and take advantage of the heterogeneous high performance computing resources. So when we say heterogeneous, these are like the CPUs, GPUs, DPUs, and even IPUs, all these. We have the exciting tutorial for you with the following outline. We'll start with a very high level overview of the introduction, followed by machine learning and deep learning frameworks and overview. Then we'll go into gradually onto the inside of the systems and how the execution environment looks like. We'll go over the distributed machine learning algorithms, deep neural network training, and we'll also take a quick look at the evolution of vision and language models. Then we'll go into more details on the data parallel training. But as you know, the data parallel training itself is not sufficient. So this is where we'll try to bring the latest trends in high performance computing architectures, challenges in exploiting HPC technologies for DL and ML, advanced distributed training, and also we'll be focusing on distributed inference solutions and distributed hyperparameters optimizations. And we'll close it with open issues and challenges. Tutorial will have a set of hands-on exercises, and as you can see here, we'll have almost 6 different hands-on exercises, starting from distributed machine learning using cuML to distributed training for PyTorch and TensorFlow using Horobot, then moving into distributed training using cluster distributed, then distributed training for language models using DeepSpeed, and finally we'll also be focusing on distributed inference using a solution we have developed in the lab called Flower, and then distributed hyperparameter optimizations using Deep Hyper. So please join us this tutorial to learn more about the principles and practice of scalable and distributed deep neural networks training and inference. The tutorial is scheduled to be presented on Sunday, 17th November in room B204, and it will be a full day event from 8:30 to 5 o'clock. And we are looking forward to seeing many of you there. Thank you.